All right, well, welcome everyone to this Tuesday afternoon webinar here. I'd like to get started right on time today. I got a lot of great information I want to get out to you guys. Um, so today we're going to be doing getting the most out of sheet metal. This is part 5 of our 6-part learning series. And I'm Jared Spaniel. I am one of the product managers here at Digital Dimensions, and I am out of the Fresno office. So let's go ahead and get started. What I want to go over today, a brief overview of what we're going to talk about. The main thing I want to focus on is sheet metal modeling methods. So we're going to go over a few different modeling methods here. And then I'm going to also have some really great tips I think I picked out for design tips for manufacturing and designing sheet metal parts. And then, of course, we'll look at why SOLIDWORKS sheet metal, what are the benefits of this tool that we have. And then I also want to throw out some upcoming content that's going to be coming up at Digital Dimensions and Desai Solutions here. So the first thing I wanted to do was kind of get to know my audience, see who's out there, see who's listening, and what are you guys actually doing. So I'm going to throw out a poll question here, and the question is going to be, what method of sheet metal modeling do you prefer? And for time's sake, I'm just going to go ahead and launch this right away. But the answers are the convert method. So this is what I consider to be, you have an existing solid to a sheet metal part. And then the flange method. So you're basically designing in a folded state. You're creating your flanges from maybe a bent sketch or an already designed sketch of, and then the sketch bends, which, you're designing from a flattened state. You're adding sketch bends. And then, of course, the other two options are, all of these depending on what kind of design I'm creating, what I'm doing, or maybe you use something totally different that I either don't know about or just don't have listed here. So feel free to throw an answer out there, and we'll look and see kind of what everyone's doing out there so I can get a feel for what I'm going to be telling you and what you guys are actually doing. So I'll wait just another few seconds on this, see if we get everyone to vote here. And then we'll continue on into the examples and some of the workflows here. All right, so it looks like mostly everyone's voted, and the general consensus is most people, I would say, looks like use the flange method, and the rest of people use all of these depending on what I'm doing. Got a handful of people using the sketch bends. Surprisingly, no one is using the convert method. Very surprised by that. Okay, that's really good to know. So let's close this out and move on. So kind of what I'm going to go over today, I'm going to go over each method and we'll give you an example. And what I like to do is highlight the general workflow of how to use the methods. Now, these are by no means super in-depth workflows. It's just a high-level workflow of how you're going to go about engaging each individual method. Then we'll go over an example, and then we'll look at some of the advantages of each method and how you might use them. Okay, so let's get started with this flange method. I figured this was going to be one of the most popular methods. Not surprised there. This is the method that I pretty much always used when I was in industry. So the general workflow here, you're going to basically just sketch and create your base flange, and then you can add other geometry, which is going to be like your tabs, edge flanges, miter flanges, whatever else you need to add to that base flange. And then you can add any necessary mounting holes you might need, and check your flat pattern to make sure you don't have any overlapping, right? Pretty straightforward. It's a good method. It's pretty common. So let's check this out real quick. I have some of this stuff pre-created just for time's sake because I did want to try to keep within the time allotted to me and respect your guys' time as well. So what I have here is I just have a sketch that I created on my front plane here, and it's just a symmetrical sketch. I added some dimensions, and all I'm going to do with this is select my sheet metal. I'm going to select my sketch, and then I'm just going to create a base flange tab from that. And you can see that automatically does is add my bends for me, and I can just grab this slider. I can drag this out. In this case, I want this to be 100 millimeters. And what we're going to be creating today in all these components is a very similar, simple component. It's just what I envision to be maybe a cover for some electronic device, or maybe the side of a computer, some kind of simple sheet metal paneling or covering for a device, an electronic component, something like that. I'm going to create the same component in each example so you can see the different methodologies behind how you might go about creating this, right? And I'm going to point out a couple other cool things along the way, like the ability here to use a gauge table within sheet metal. So you guys can create your own custom gauge tables with, if you want to use K-factor, bend allowance, bend deduction. I'm just going to use this sample aluminum table here in the metric. And what this allows me to do is it gives me a drop down for all the gauges that I have within my table. So in this case, I'm just going to stick with a nice thin 16 gauge part. I'm going to keep all the defaults for my thicknesses, for the K-factor and everything like that. And I'm going to go ahead and check out of that. And you can see I was able to create these flanges and these curves all within one sketch, right? So that's one thing to note here. Now, if I want to add the bottom kind of covering, so we'll say that this this is a housing. There's a component within here that this slides over. I'm just going to use an edge flange, and I'm just going to create this back side of this and bring it down. And I'm going to utilize the I just want that to be a simple edge flange, and I'm just going to go up to a vertex here. And I just want to select the vertex. Or an edge for this to go up to. So in this case, I can just bring it up to this edge. Or up to vertex was what I wanted here. And I can green check mark out of that. And then I can add the other flange that I need to have to complete the design here very simply. So you can see that this is requiring me to make a couple of extra edge flanges here. So I want this to be about a 1/2 inch, so call that 12.5. And I'll check out of that. And now you can see that I've pretty much created that geometry, right? Very simple. Was able to create the planar flange part with the bends, and then I just added my 2 edge flanges to cover up the back end. And now I can go ahead and add any other geometry or put mounting holes in here wherever I like, stuff like that. So very simple to do that method. That's probably why it's so popular, right? So the flange method, we looked at some of the advantages. It's going to be your most conventional method, and exactly what we saw from the survey. Most people use this method. You can create multiple bends in one feature, which is great. So easy to create complex sketches and capture the overall shape of the part within one sketch. I've actually utilized this quite frequently in industry where there was a complex bracket or something that needed to be created that had a bunch of planar curves and bends in it. And you can just create those all in one sketch, very simple to do. So the next one I wanted to look at was the convert solid to sheet metal. And I'm surprised that not more people are actually using this method. It is a great method. It is less used just because most people that are designing in sheet metal are already designing in sheet metal, so they don't design solid parts and then convert them. But what this is good for is if you already have parts that are modeled, or you're importing a part that has conventional solid modeling techniques, and all you have to do is select the convert to sheet metal command and then select some faces and edges to convert that part. So let's take a look at how we might go about this. And I already have one of these examples in here. So maybe I received something like this. This is the housing cover. Somebody modeled this geometry. It's just a solid boss with some hole cuts, and I patterned the holes, right? Very simple part. But I want to actually make this a sheet metal part. Here's your convert to sheet metal tab right here, or command, I should say. All I have to do is invoke that command, and then it's just asking me what face I want to have as my fixed entity. In this case, I want it to be my top face. And then it's just asking me what bends I want. Now I could do collect all bends, and that'll pull all the bends, but in this case, I don't want a bend here. I want that to be open. So I'm just going to select the 3 edges that I do want to have bent. And then you can see it's already making a smart selection here for me to rip some of the edges. And I can do different corner defaults if I want. I'm just going to leave those all as a default. I am going to utilize this gauge table just like I did before as well. Very simple. I'm just going to pull the gauge table from the sample I already have in place. And I'm just going to select the gauge that I want, which was a 16 gauge. And I'm going to check out of that. And now you can see that it's actually created my 3 flanges for me. And now all I have to do is go in and finish this off with my edge flange. So I'm just going to create my edge flange here. I'm going to add a dimension. It was about 1/2 inch. And the cool thing about edge flange, if you didn't know, you can create multiple edge flanges within one command. So I'm just going to grab these other 3 or these other 2 edges here, which allows me to have those mounting flanges on there that I need, or maybe they slide over another piece that's behind it. And there you go. I've created the same exact part with the convert solid method and just adding a few edge flanges, right? And the holes that I had, these are mounting holes, I'm calling them, that mount to some kind of electronic component that's sitting under here or the backing of a computer. Those carried right forward for me. So a great thing if you have a lot of really complex holes that are dimensioned on the original part, you know, maybe somebody designed a plate or a panel for you in a solid for a prototype or a test fit part, and there's a lot of complex mounting holes or something of that nature, and you don't want to have to redo all that work, you can just, you know, transfer that over to sheet metal and it'll carry forward those hole locations for you. So some of the advantage of the convert to solid feature in sheet metal, like I said, it's great for imported parts or parts that are already created as a solid model. So if you're working with possibly an outside vendor or another design firm, or you're just somebody's doing some prototyping for you and they're bringing in solid models because maybe you don't know if they're going to be sheet metal down the line, and then you decide later on that you want to lighten things up and cheapen it up, you can convert those solids to sheet metal very easily without having to redesign all that stuff. So it saves time from having to start over. It's easy to identify the pre-existing outline shape of the part, so you pretty much know what the sheet metal part's going to look like when you look at the solid, and you can select the different fixed faces or the different bend edges depending on how you want to utilize those components or those features. And one to note, it is best suited for standard parts, so those are things like non-thin walled or shelled parts, right? So just solid standard parts. It's easy to carry forward your instances of geometry already created. So those are things that I'm thinking of, like mounting holes, or if you have really complex hole patterns, you'll be able to carry those forward without having to redo all that dimensioning and work. So let's look at the last one. The last one's the sketch bend method. This one, probably one of the less used methods, but it has its advantages. So the workflow here is you're just going to start with a base flange in a flat state, pretty simple. And then you're just going to add those sketches where you want your bends to be located, and utilizing the sketch bend tool to create bends. So let's take a look at the example that I have here for the sketch bends. So this is the same exact geometry that I had for the other components, just in a flat base flange example here. And one thing I did want to point out with the sketch bends, they're really good if you're doing some angled bends or something like that. So in this case, I can just do a sketch bend. You can see I have some of these sketches already pre-created, but you don't have to have them pre-created. You can do them on the fly. In this case, I'm just going to use the convert entities. I'm going to show you one example of the sketch bends with an angled bend here. And it wants me to select my face. So you can see the black dot indicates that this is the fixed face I want, and then this is my angled bend. I can flip the direction or control the bend position, and I'm just going to check out of that. And what you can see here is I have that angled bend, right? Pretty easy to create that. Now I'm going to go ahead and delete this. Going to delete this sketch, and then I'm going to go and show the initial creation of the part that I wanted to create, the initial geometry, right? So I'm just going to do the sketch bend once again, so you guys can see how I did this again. I have the sketches already created, so like I said, I can do it on the fly, or I can just utilize the ones I have already created just using the convert entities. I'm going to check out of that. It drops me right into my sketch bend command here. And then it asks me what face I want. I want this face. I want the direction to be down. That's pretty much what I want it to look like, right? One thing to note here is the bend position based on your overall. So I did want to note that it may take a little bit more calculations based on this is a really simple part, so it's easy to calculate, right? I knew I wanted these to be 25 millimeters long, and I wanted the overall part length, the part length to be 150. So just be careful whenever you're doing this. The sketch bends may require a little bit more. You'll see that because I had my base flange, what I did was I calculated my base flange to be 200 to account for that. So now I can take away the 25 millimeters on each side and still have it be 150 total. It's pretty simple math in this case, but if you have something really complex that's especially going out to decimals or something like that, just be careful of this, utilizing this method. That's one of the kind of the disadvantages here. You'll see here if I do the evaluate when I measure this, that I did it correctly. I have 150 millimeters, which is what I wanted. But if you don't do it correctly and maybe you selected this center line, so if you go off the bend center line here, you'll notice that it actually lengthens my part up. So if I do that and I don't pay attention and I have this made right and I know I want it to be 150 total, you'll notice now that it's actually 152.47 millimeters, which is not what I wanted. So just be careful of where you put those bend positions based on how your overall dimensions and what your overall design intent is, right? So in this case, I actually want it to be the 150. And now I would just have to go in here and add all my edge flanges just like I did before, right? So I would just go in, add my edge flanges, do my up to edge here. Or up to vertex. And then put my other edge flanges on, right? Exactly like I did before here. I wanted that to be 12.5, and then I'll just select my other two here, just for the fact of finishing the part off. So we've created the same exact part. A couple more features and a little bit more work to create that one, and a little bit more calculations on the back end, but you know, it's a method, it's there. I don't think it's that commonly used for this part, especially. It's definitely not the best method for, you know, creating this part, but it does have its place. If you have a tab that's coming off here, like a straight tab or something like that, or another feature, and you just want to add a quick sketch bend on it, it might come in. It comes in more handy for that type of stuff. But I did just want to show it as being an option. So some of the advantages of the sketch bend, like I said, it's good. It's really good for creating those angled bends on flat parts, like I initially showed. It makes it really easy to create things like bent tabs. If you have a bunch of tabs that you're trying to bend that are like going to be mounting hole locations that are tabs, you can utilize that sketch bend tool real easily. It is a quick way to add bends if you don't want to use the edge flange. Some of the drawbacks I thought were, I don't really recommend it for creating multiple flanges or many simple bends, just like I kind of just did. So the edge flange is, a better tool for that overall. It's just a lot quicker and easier to use and has more control as well. This one, like I showed before, it may require more pre-planning on your overall dimensions, so you need to account for the flanges initially. So if you have a part that you want it to be 125, but you want the flanges to be 25, you need to add those in and pre-account for that type of stuff. So it just may require a little bit more pre-planning, right? Some of the manufacturing tips I wanted to just basically point out and get out there for you guys. Maybe this is a refresher, maybe it's new information. Just remember your parts must be a uniform thickness. That's pretty self-explanatory in sheet metal, right? It's going to be created from a uniform sheet part. Make sure the model flattens properly. So if you're doing a lot of bends and stuff like that, just check the flattened pattern at the end and make sure you don't have any overlapping areas or overlapping features. This is a good one that I always like for manufacturing. If you know what tooling is available to you beforehand, you can reduce your costs. So this includes things like your forming tools, sizes, what bend information you have, and the K factors. So it's good to know what the shop or the vendor you are using already has. Otherwise, if you design things they don't have, they're going to have to go out and buy those things. So that's going to be a cost that's passed on to you. Whenever possible, keep your inside bend radius equal to your material thickness. I think that one's pretty self-explanatory. the shortest flange legs should be a minimum of 4 times the material thickness from the bend line. Good guideline there, just giving them something to grab so they can actually create that bend when they manufacture it. And then same kind of general, same thing with the holes. Whenever possible, your hole location should be a minimum of 4 times the material thickness from the bend line. And that's basically just to prevent any hole distortion or hole bending whenever they're creating that bend, so the hole doesn't actually get picked up with the bend and get deformed, right? So just some good tips and best practices I wanted to add for you guys to have there. Some of the benefits that I put on there for sheet metal, we have a lot of advanced features for sheet metal design that, unfortunately I couldn't really have time to get into everything today. There's so many of them. Things like welds, corner treatments, additional types of bends, miter flanges, all those types of things. The ability to create custom gauge tables. So if you want to create your own custom tables, that's great. You saw me use those within my examples here. You can easily view the flat patterns and verify your geometry, so it flattens it for you. And of course, the big one I always like to throw out there, huge cost and time savings with SolidWorks, and especially SolidWorks sheet metal with all the features they give, right? Some of the upcoming content I just wanted to point out there for everybody. Reminders, August webinars, one left, I believe, this month, and that's going to be technical documentation. So that's on Composer this Thursday at 1. And then we have the final 20-minute learning series in September. That's 9:20 at 1, and that's going to be on weldments, titled The Backbone of SolidWorks Structural Design. So I hope you guys will join me for that, and I'll be doing that one as well. And then also want to remind everybody, it's that time of the year almost again. It's SolidWorks 2017 rollouts are going to be coming in October to a location near you. So all that's still, in the works, TBD out there, but just make sure, just want to give you guys a heads up that it is coming. I've seen a lot of the new stuff for SolidWorks 2017, and it looks awesome as usual. Lots of great stuff to show you guys. So make sure, that you think about attending one of our rollout events wherever you are. And then also want to remind everybody, I did put together a short survey at the end of this. I had 3 quick feedback questions I just want to throw out there. So if you guys just do me a favor and complete that, there's going to be an option to complete it directly at the end of the webinar, or it'll be attached in the follow-up email. Just really appreciate your feedback. It's going to be, feedback on this webinar and then following webinars, just to see what you guys are interested in and how you feel about the webinars, right? So that pretty much concludes the bulk of this. I just want to thank everybody for attending and taking time out of their day, and remind everyone, think about how SolidWorks sheet metal can help with any upcoming projects you have. And of course, don't forget to follow us on social media, on Twitter, DDI-CAD, or on Facebook and LinkedIn, Digital Dimensions Inc. And thanks everybody for coming. Reminder, my name's Jared Spaniel. My contact info is there, jspaniel@ddicad.com. I'm going to hang out for a few minutes, answer any questions. Feel free to submit anything or call me, email me, whatever you need. All right. Thanks a lot, everybody. Have a good day.